Hi, my name is Isela Valeria Salgado Telles. In this video, I will present the technical, economic, and ethical analysis of a cascade refrigeration system using R134A and R1234YF, and I will explain the final decision for the refrigerant selection. Okay, so now I'm gonna give you a little bit of context about the case. Well, Technocool is designing a new refrigeration system for a dairy production plant. The client needs a reliable 24/7 operation, a strict temperature control, and a competitive cost. As a project leader, mechanical engineer Carla Mendez proposes a two-stage cascade system. The lower cycle operates between 200 kilopascals and 0.5 megapascals, and the upper cycle between 0.5 and 1.2 megapascals, with heat transfer in an adiabatic counterflow heat exchanger. In both cycles, the refrigerant leaves the condenser as saturated liquid and enters the compressor as saturated vapor. For the technical analysis, thermodynamic properties were obtained from tables. Using the same mass flow rate of 0.5 kilograms per second and the same pressure levels, I calculated enthalpies at all state points, compressor work, and refrigeration capacity in each cycle. From the environment point of view, the difference is very clear. R134A has a high global warming potential, so leaks contribute strongly to global warming. R1234YF has an ultra-low global warming potential, close to zero. This means that the new system with R134A face increasing regulation and economic risk during their lifetime, while systems with R1234YF are much compatible with future regulations. According to ABET student outcome form, engineers must recognize ethical and professional responsibilities and make informed judgments considering global, economics, environmental, and societal impacts. In this case, Carla cannot look only at the short-term cost and schedule. She knows that R134A will likely become restricted, that it has a much higher climate impact, and that the client may have to pay for expensive retrofit in the future. As a professional engineer, she must use her technical knowledge to protect public welfare, to be honest with the client, and to support a sustainable solution, even if this is less convenient for the company in the short term. The ethical dilemma is the conflict between on-time, low-cost delivery using R134A and a more sustainable but more expensive solution using R1234YF. On one side, management wants lower capital cost and no delays, and they argue that R134A still complies with current regulations. On the other side, R1234YF offers lower emissions, better long-term efficiency, and lower regulation risk. Carla must decide whether to accept R134A, designed to satisfy management, or to push for the R1234YF option that better protects the client and the environment. Carla has several alternatives. First, she could simply accept R134A and design the system with standard components. This satisfies management but ignores long-term environmental and regulatory impacts. Second, she can formally recommend R1234YF, presenting a detailed life cycle analysis comparing energy use, operating costs, and CO2 equivalent emissions. This option increases initial cost but provides clear long-term benefits. Third, she can propose a hybrid or transition plan, design the system R1234YF so that conversion in the future is easier and cheaper. Finally, if management refuses to inform the client about this issue, she may need to escalate her concerns to ensure that the client receives complete and honest information. Considering the principle of engineering code of ethics, the best option is to adopt the R1234YF cascade system and clearly communicate this recommendation to the client. This decision reduces lifetime emissions, improves energy efficiency, and anticipates future regulations. It also shows respect for the client's long-term interests and for society's demand for sustainable technologies. If the client still insists on R134A after being fully informed, the system should at least be designed to allow an easier future conversion, and Carla should document her professional recommendation.